Hello everybody, this is Chapter 6, 6.1 review. We are dealing with exponential functions. Y equals A times B to the x power. And if we have B being greater than 1, then we have something called exponential growth. Alright, and therefore it will be kind of this line that kind of just creeps above your x-axis, or just gradually grows, and then it shoots up eventually. And what we have is something called an asymptote, and that's where the graph approaches more and more closely. That's this x-axis right here. We will always have something like this, 0, 1. You plug in 0 for x, anything to the 0 power is 1, and you're going to get A, in this case 0, 1, for this function right here, y f of x equals p to the x power. And then if I plug in 1, right, b to the first power is just b, so there's that 1b point right there. So those 2 points are on there. And then after that, you can find. Anyway, again, all exponential growth is going to kind of look like this. It's going to kind of go down and then shoot up off the graph. And a great example of this, as you guys know, is the coronavirus. All right. So range y is greater than or equal to 0, meaning it does not go into any negatives. So again, it starts at 0 and only goes up. We also have exponential decay, and when that happens is when b is in between 0 and 1. Alright, and exponential decay kind of looks just the opposite of this. We start up on top and we shoot down, and then we kind of flatten out with that asymptote. Alright, that x-axis. Same thing, 0, 1 is going to be a point, 1b is going to be a point. And again, that's just shooting down. Alright. Flip. Alright. Graphing exponential functions. Well, all we're really going to do is plug them into a table, a function, and graph. So,
what are you going to do?
What I do, and again, is I make these x or horizontal tables.
Are you making x's?
Teaching exponential growth, but okay, so here we go. B is 2, and if B is 2, which means it's greater than 1, that is growth function. Alright, growth function. Alright, also I'm going to go ahead and make 5 points, and I'm just going to use the 5 kind of general, easiest points we can use. And they are going to be really close to this y-axis. That way, they don't really get off my graph for the most part. Alright, so what points am I going to use? Negative 2, negative 1, 0, 1, and 2 for our x-coordinate. And then I'm just going to plug them in. Alright, so when I do that, a negative exponent is going to make a fraction. And it's going to be 1 over 2 squared, and that's 1 over 4, 1/4. Negative 1 in there, that's 1 over 2, or 1/2. Put 0 in there, anything to the 0 power is 1. Put 1 in there. 2 to the first power is 2. Put 2 in for x. 2 squared is 4. Now I have my 5 points. I'm going to plot them right on the graph. -2 1/4. I go 2 to the right, up 1/4, right about there, estimated. -1 1/2, right about there. 0 1, right there. 0 right or left, just up 1. 1 2, 1 to the right, up 2, and then 2 to the right, up 4. 1 2 3 4. All right. And if I put 3 in there, I could get 8. So there's 4, 5, 6, 7, 8, just if I wanted. And you can see it's shooting up. So it's going to kind of really just kind of creep above that x-axis and shoot up. That x-axis is the asymptote.
Are you talking to yourself?
I'm talking to the camera, bud. I'm trying to teach this. Emmett, get that out of your mouth, buds. Y'all go. Okay. Exponential growth looks like so. Alright. Same idea over here for this second one. Alright. And I'm going to go ahead and make a table.
Is it your hand?
It's the video camera, dude. I'm trying to teach a lesson.
Can we calm down and do something and do ABC mouse?
You want to do ABC mouse?
Yeah.
Yeah.
Here you go.
Yeah.
Yay! I mean, you want to do ABC mouse? ABC